Number patterns is a very important topic for any test, exam, or even competitive exams. And when we talk about non linear number patterns, it becomes a challenge. So, in our series, we are going to take up very challenging questions, go through the playlist to understand more. Three of them are discussed in this particular video. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are getting admission to the best universities and even some of them get with scholarship. Great. Now, let's look into solution of these nonlinear number patterns. These are considered challenging questions. We will adopt some strategies which will make them very simple. So, here is the very first one. In many competitive exams, you see choices. So, we have also given you four choices to make things simpler. So, the question here is write the 12th term in the sequence 1, 3, 6, 10, 15. How do you find the pattern? Now, 1, 3, 6, 10, 15. If I go with the first difference, 1 and 3, the difference is 2. And between 3 and 6, it is 3. And then it is 4. And then it is 5. So clearly, we notice that it is non-linear. But if I find the second difference, there it is 1, correct? That means it is quadratic. Means something like term number square is involved, right? So in the first term, so means we have to use square of a number. So our equation will be x times something. You get the whole idea, right? So that gives you the kind of concept here. So it's non-linear. Perfect. How do we now get into the solution? So basically, when it is non-linear, you are multiplying the number position by something, right? So let's see, how do we get from 1 to 3 to 3? These are term numbers. So let's write down the term numbers. I'm using this hash for numbers. So this is my term number 1, this is 2, this is 3, this is 4, this is 5, and we have to find the 12th term. Now, if it was the next term, I would have easily got, right? Adding 6, I know it will be the next term. So we need a strategy. Now, we have to now analyze and understand how do we get 1 and how do we get 3? Well, second term gives you 3, the first term gives me 1, and third gives me 6. So, how about doing 1 times 2 divided by 2? It gives me 1. Do you see that? Second term, if I do 2 times 3 divided by 2, that gives me 3. And similar pattern, if I use, let's say the third term, I do 3 times 4 and then divide by 2. I get 6. And for 10, I get 4 times 5, which is 20, divided by 2 is 10. So we get a formula, right? So what we did was we multiplied 4 with 5, right? Next number to get our answer. So what should we do for the 12th term? We should do 12 times 13 divided by 2, which is 6 times 13, correct? And that gives you the answer, which is 78. And therefore, option C is the right option. So in this particular case, what we did was we derived a formula, right? We also call this as an explicit rule. Explicit rule, right? N times n plus 1 divided by 2, where n is the term number, right? Nth term. This is better, right? That will give us the nth term Tn. This is the correct way of writing it. Is that clear to you? Right. So we use this particular formula to get the result. Great. Now let's look into this second question. I hope you understood this strategy. In case you want to learn more tricks, send an email to globalmathinstitute@gmail.com and master these strategies. This time we have a sequence which is 1, 3, 8, 17, 31, 51. How do we work with this? Let's find the first difference as we did. 3 minus 1 is 2. And then 8 minus 3 is 5. And then 17 minus 8 is 9. And then 31 take away 17. So 11 take away 7 is 4. And then 2, 14, right? And then from here to here it is 20. So that is the first difference, which clearly is not constant. So let's find the second difference. 2, when you take away from 5, it is 3, and then here it is 4, here it is 5, here it is 6. We do get a pattern that it adds up by 1 as we move forward. Now, the question is not to find a general formula, but just the next term, right? We just want to find what comes here. Can you work it out? Great. We need to find the next term. What do you think should be the next term? Well, as you can see in the sequence, we are adding one number more to the next one. So, after 20, I should add what? I should add 7, right? And I'll get 27. Now, this number 27 will be added to 51. So, we have 51 plus 27 to get the answer, which is 78. So, the next number is 78, option C. You see how using the concept of first difference, then second difference, and then recognizing the pattern, we could get the next term. Perfect. Okay. Now, finding a general formula is an exercise for some of you who are ready to take at a senior level challenge questions. Perfect. Let's look into the third question, which is kind of a practice test question for you. Here, write the next number in the sequence, right? So let's follow the rule. First, difference is 2, then it is 6, then it is 18, and then how much? Well, from 12, if I take away, it is 4, and 7 and 2 will give me 5, right? 54. So what is happening here? You see, each time 2, 6, 18, 54 means it is times 3, right? So this difference, let me call this difference is times 3. So from here we can figure out what could be the next number which is to be added to 82. It has to be 54 times 3, right? So 3 times 4 is 12 and 15 and 160. So we have to add 162 to 1 to 82, right? So 162 should be added to 82. Right? 6 and 8, 14, 4, 1, 244. So we get the option D, which is 244, as the right answer in this particular case. So the whole idea is to find the finite differences. As soon as you recognize a pattern, you may do the needful reverse calculation to get your answer. Is it making sense to you? Perfect, right? And It is never too late to learn. Send an email on globalmathinstitute@gmail.com to master strategies and do extremely well joining the university of your choice. Thanks for your time and all the best.